describing transformations, you're going to be sketching a little bit, okay? But the calculator will do most of the points for you. And then write transformations of polynomial functions. So you're going to come up with what they look like. So everybody take good notes today, as always. You can transform graphs of polynomial functions in the same way. You can transform graphs of linear functions, absolute value functions, or quadratic functions. So depending on where the numbers are, it's going to either shift it right, left, up, or down. It's going to reflect it either over the x-axis or y-axis. It's going to stretch or shrink it horizontally or stretch or shrink it vertically. So refer back to this chart as needed, especially during your homework. Okay. But horizontal translations are going to be grouped within parentheses. So within polynomials, the exponent will be outside of the parentheses. So that would be an example of the fourth power. It can be the 10th power, it doesn't matter. If it's grouped with x, either plus or minus a number from x, that's going to go right or left. So it's opposite sign, if any of you remember. So a minus 5 inside parentheses, that would be 5 units to the right of the origin. And then a plus on the inside would be to the left. So those are opposite of what you normally think. Okay, so pluses to the left, minuses to the right. A vertical translation, meaning a shift, that will be completely separate, no parentheses. It'll be after all the x's. That's the constant on the end, which would be the y-intercept of most functions. So that will be up for a plus, down for a minus. So these are normal signs. Those will not be in parentheses. Horizontal is in parentheses after x. Any questions on the translations? Who does this look familiar to? Ringing a bell a little bit at least. Okay. Reflecting. It depends on if it's over the x-axis or across the y-axis, which is a little bit less obvious. But if there's a negative, we'll see this one more often. So if there's a negative, no parentheses, it's just out front. So on the quadratic, that's when a was negative and it opened down. That would be a reflection in the x-axis. So it's technically a horizontal reflection, but it looks like it flips upside down. Over the y-axis, the negative would have to be within parentheses with x. Okay, so there's a difference there. So that would reflect it across the y-axis. That's a little bit less seen, okay, but it happens. So it's just where the negative's located. Inside parentheses over the y-axis, outside parentheses over the x-axis. A horizontal stretch or shrink. So that means the graph is stretched away from, or shrinks towards, or is compressed towards the y-axis. Now this one, a lot of people get confused. So if there's, again, parentheses is going to be towards or away from the y-axis. Okay. So a stretch, it's going to get wider, farther away from the y-axis. A shrink, it's going to get closer. And you're going to be listing by a factor of. So this would be, these are less used, but this would be by a factor of 1/2, so it's reciprocal. This is a stretch by a factor of 2, and vice versa. I'm actually going to reword those for you when we get to those. But a vertical stretch or shrink is a stretch away from or towards, a shrink towards or compression towards the x-axis. So a stretch would look like it's stretching up, so the graph is going to get steeper. And then a shrink or a compression, it will kind of squish down towards the x-axis. But if you notice, there's no parentheses there. So if it's in parentheses, it's horizontal. If it's outside parentheses, it's vertical. Questions on anything up here? Okay. So for the first one, we're going to describe the transformation. So if f of x is the parent function of the more basic function, we're going to describe what g of x is in terms of that, so where it's going. And then we're going to graph both, and that should reflect that. So what's one transformation that's happening in g of x from the original f of x function? So if it goes from x cubed to x plus 5 cubed plus 2, what's happening? Okay, so the graph of g, so g is translated or shifted, it's the same thing. Left 5 units. Okay, that's the plus 5 on the inside. What else? And then up 2. So anything outside parentheses after it was vertical. And up 2 units. So when we graph these, this is going to be the f of x function. This is going to be the g of x function. The g of x function should look like it moved left 5 and up 2 from the original. Okay. So now's where we're going to pull into the calculator. Is there any questions on how we figured that out? You could wait till you graph it, but you won't always have to graph. So we can actually plug in both functions at the same time, but keep in mind it's going to have multiple columns, so if that confuses you, then just do one at a time. So x to the 3rd power, do you guys want to do both at the same time or separately? Okay. If you want to do them both separately, that's fine. Enter them in exactly as it is on your paper. So parentheses x plus 5, and then to the 3rd power on the outside of the parentheses, and then the plus 2. So make sure it looks like that. Okay. Everybody good? Hit graph. Okay. So on mine, the blue one, which is towards the middle, that's the f of x function. Does this look like it went left and up 2? Mm-hmm. Yes. Okay. Nothing else happened to it. It didn't get steeper, shallower, none of that. It just shifted. So our points when we graph it should reflect that. Now the coordinate plane I gave you, it's like an 8 by 8 by 8 by 8. So we won't be able to go very far on these. So fit the amount of points that you can in there. So the blue column, that is the f of x one. So we can fill in the points that we can do. So from -2 to +2 on that one. So it was -8, -1, 0, 1, 8. So that is your f of x function. You can plot it as we go. So try and capture the shape if you can. And then as many points that will fit on this one. So we're looking in the red column. So since it's only going to go to -8 to +8, technically -7 to -4 would be the only ones that would fit. But graph how many can fit. You don't have to plug anything in, but you can. Now one thing you could do on your homework tomorrow, you're going to be graphing both the f of x function and the g of x function. So I should see the shift that happens. If you graph the original, if you move all, however many points that you did, up 2 and left 5, so the one of the origin would be right here. This one would be up 2, left 5 right there, up 2, left 5 over here. So they should all line up that way. So you could just graph one of them and then just shift the points. However, if it's a reflection, that's a little bit harder to do. So use the calculator to help you with that. But it should look like what you set up here. So if you want to wait till you graph it, just to make sure, especially with the right and left, that's what you need to do. Questions so far? All right, we're going to graph one more, and then the rest of them we're going to be writing. So, our f of x function is x to the 4th on this one. G of x is -1/4 x to the 4th. What does the negative tell you? reflected where? Reflected in the x-axis. So function g technically is function f, but you can say is reflected in the y-axis. Now there's no parentheses, so that means it's a vertical shrink or compression. Okay. Vertical shrink or compression. So you can say vertically compressed, but you can say and a vertical shrink, whatever you want to word it as. And then you say by what? So you say by a factor of 1/4. But if you say by 1/4, I'll get the message. If that 1/4 was in parentheses with x, that would be just a horizontal stretch. So it switches both words on those. So a horizontal stretch and a vertical shrink are the same thing. Yeah. Mm-hmm. So it's vertical because there's no parentheses. So then between a stretch and a shrink, if the number is larger than 1, it's a stretch. If it's a fraction less than 1, it's a shrink. It gets wider, but it gets closer to the x-axis is what happens. So it's squished versus the original one. Right. So this one should be flipped upside down over the x-axis, and it should be a little bit wider, which is what a vertical shrink is. Okay, it'll be closer to the x-axis. So back to y equals, clear these out. We have x to the 4th power as our f of x function. Now it's negative 1/4. Type this in carefully. Okay. You either do in parentheses negative 1 divided by 4, but group it all together, and then x to the 4th power, but it's all of negative 1/4 times x, so be careful with that. Or you can do negative 0.25 x to the 4th, which would be the same thing. But if it's 1/3, keep it as a fraction. So is that a reflection? And is it wider? Yeah. Okay. Now this is not fully a U shape, so the 4th power ones, it looked like the W that we did yesterday, but the W is just really close together. So it's just gonna look like a wider parabola. I'm not gonna be picky on your hand-drawn graphs. So again, these are 8 by 8s, so we're only really gonna have a couple points on the original one. So from -1, 0, and 1. I won't be picky on what you use. Just do the ones that fits, but capture the whole shape. Alright, that's 1, 0, and 1. Okay. So use the points that can fit, because these two, unless you go by 2s, the negative 216 and positive 216 aren't going to fit. Alright, so just try and capture the shape. Graph the points that'll fit on the graph. So the 4th power ones kind of have almost a flatter bottom to their U shape, but again, I'm not going to be picky with your hand drawings. And then how many points from the other one can fit on my graph? From -2 to +2, because it's a little bit more shrunk. So you can keep it as decimals, or those are -1/4, both of them. So -2 to +2. So you can use the decimals or the fractions. So horizontal shrink means it's going to look wider, or sorry, vertical shrink means it's going to look wider. So it is slightly, and it's flipped upside down due to the negative. Questions on anything we've done so far? I'm taking your silence is that you understand. So make sure you ask me something if you're not sure. Okay, the rest of the time we're not graphing, we are writing new functions and describing the transformations. So let f of x for both of these be x cubed plus x squared plus 1. So that's the original. We're going to write a rule, meaning an equation for g, and we're going to describe the transformations that's happening as well. So I'll tell you what to do here, but saying g of x is f of negative x. So looking back at your chart on the front, what if we were to graph that, what transformation is that? A reflection in the y-axis. So this, because it's in parentheses, would be a reflection in or across the y-axis. If the negative was out front of f like that, then that would be a reflection in the x-axis. But since it's in parentheses. All right. Now what this is asking you to do is plug negative x into the g of x function. So this is what we're plugging in everywhere there's an x, and then we're going to simplify it. So this is how you would write your rule. So the negative x is going to replace all the x's in the original function. So whatever's in there, you're going to plug in. Now we have to simplify however we can. Now negative x to the third power. Technically there's a negative 1 right here. What's negative 1 to the third power? Negative 1. So an odd amount of negative signs, it's going to stay negative. So this would be a negative x cubed. What about negative x squared? So negative 1 squared is a positive, so it's going to be plus x squared and plus 1. So this is what a reflection of the y-axis would look for that original function. That's the answer for that. Now for B, it's saying g of x is 3 times f of x. So what's happening with that function? If you go back to your table, is that 3 within the parentheses or no? No. Okay, which means that would be a vertical stretch. Okay, so it's outside. So it's kind of a magnification of it. It's going to make it larger. So this 3 is a vertical stretch. If you want to be specific, you say by a factor of 3. So that means we're going to multiply the entire function of f by 3. Three times the f function. Any questions on how that's set up? Now the last thing I need you to do is distribute the 3. Okay. Distribute the 3 in there, and then we would have our function. It would be 3x to the third plus 3x squared plus 3. So if this was the original function, a vertical stretch by factor of 3 would look like this. If that was the original function and we want to reflect in the y-axis, this is what that would look like. Questions before we keep going? We're going to kind of do that again for the last one. However, it's not going to give you exactly what to do. But use the previous examples to help with that. So let the graph of G be a vertical stretch by a factor of 2, followed by a translation 3 units up of the graph of f of x equals x to the fourth minus 2x squared. Write a rule for G, meaning a new equation. So how is a vertical stretch by a factor of 2 shown? So would the 2 get distributed in? So it's 2 times the entire function. So if you want to write it out, so g of x is going to be 2 times the f of x function. Anything else happening? And then up 3. So how do we show that? You're going to add a 3 on the end. So the f of x function is going to go right here by substitution. So we have g of x equals 2 times our f of x function, x to the 4th minus 2x squared. And then the plus 3 gets tacked on the end. And then you will simplify by distributing the 2. We have 2x to the 4th minus what?
2x or 4x.
4x squared. And plus 3. Do we have any like terms? No. If you did, you would need to combine them, but if you do not, then you're done. Just make sure it's in descending order. So this function would be this function, just magnified, stretched by 2, and then moved up 3. It's just a little less obvious when it's all distributed like that. Okay. So use the chart as needed